for another programming concept, this time on interfaces. We're in main activity and we've got our fragments switching out nicely with manual button click listeners. So all we need to do to hook this all together is get the fragments to switch from the bottom navigation view. So above those buttons, if I type binding.bottomNav, well, similar to a button click listener, we need a certain type of listener for our bottom navigation view. And I can go ahead and tell you what that is. It's called a navigation item selector listener. So I can see you've got this set on navigation listener. I'll just choose the top one for now. And this is expecting a bottom navigation view dot on navigation item selector listener, which is a bit of a mouthful, okay? And very similar to our on, it's the thing that we need to register when it's been interacted with, when it's been clicked or selected. So underneath this, if I go ahead and type out that interface, so on navigation item selected, and I'll choose the top one that says bottom navigation view on the right, okay? If I now command click or control click into this, we can look at the code for what this listener is. Okay, and back in Java, which is why I insist on teaching Java in my courses. But yes, we have public interface on navigation item selected listener. So this is an interface, something we've not discussed before. I can see it looks a little bit like a class, and then there's one method. It returns a boolean, a true or false, and it's called on navigation item selected. But when I look at this, I can see there's no actual code. It's just what looks very similar to a class with a class name or interface name, and then a method, but no method body. So if I just close out of this, so we've seen something like this before with our button click listeners. If I just underneath type the view.onClick listener that we've used many times, including below in those curly brackets, when I command click on the onClick listener, again I see public interface onClick listener. Looks a little bit like a class, except the word interface, not class, and a method, but no method body. So rather than diving in and just me showing you the code to type out and copy out for this navigation item selected listener, now is the perfect opportunity to finally understand a little bit about what interfaces are and why we might use them. So I'm going to go ahead and remove all the code now after set content view, ready to do this properly. And it's time to file interfaces. So in the project pane, I'm going to close the top folder, the project folder. I'm going to open up Scratches and Consoles, and then Scratches. And I'm going to put the file in the main Scratches folder. It's not a Kotlin Foundation tutorial, it's a general programming concept. So right click on Scratches, new Scratch file, and make sure we select Kotlin. Now, normally I would go ahead and rename this straight away to interfaces, but I've been finding that these Scratch file warnings and error highlighting doesn't really work sometimes if I rename it first. So I'll do the renaming at the end. But this Scratch file is where we can learn about interfaces. So I'm just going to go ahead and close the project pane, and we can work in here now. So the first thing I'll do is I'll put a heading for the Scratch file, so a comment / and then 3 stars, and then interfaces, our programming concept. And we're going to start with the what. What is an interface? What does it mean? I remember early on in my programming career hearing about interfaces, knowing of them, but being a bit scared to really dive into what they are and what they mean and why we would use them. Interestingly, interfaces themselves are one of the simplest concepts, but understanding the purpose and where they fit in can in many ways be one of the most complex that we've seen so far. Okay? So I think a really good place to start with getting our head around what interfaces are is with the actual definition of the word interface. If I just head over to a browser and type define interface, and we'll go for the noun, interface as a thing, a noun, a point where two systems or subjects, organizations, etc. meet and interact. Okay, so I'll take the first part of that. So a point where two systems or subjects meet and interact. So let's bring that definition right into our Scratch file and build upon that. This time I'll do a code block, so / star and then enter. I have a code block and I'll do a tab. So definition of interface. A point where two systems / subjects meet and interact. And if we actually take this definition, it actually fits very nicely with what interfaces are in code. What I'll do to make this definition a little bit clearer is I'll give a very simple example to illustrate it. So let's take, for example, a computer user, and that user might interact with a computer. Okay? So if you think about this, a person sitting in front of a computer, wanting to do things, wanting to interact with that, and then the inner workings of the computer, the circuit boards, the hard drives, and the motherboard and the processor. Well, there is the user interface. For example, Windows, Mac OS, Ubuntu if you're a Linux user, etc. Okay? Let's think what using symbols. So a very simple, so the point I'm trying to for directly reading the bytecode data. But the important thing is the interface sits in between two parties, two subjects. So with lowercase r, so we're going to have the person, what, and then serve to offer it. And this time something implements this interface when something says, hi, I am a coffee provider, let me roll out those methods, let me do that behavior. So the interface itself is very simple. So let's make a note saying exactly this. Interfaces are very simple. In terms of how we do it, we type interface, then the name of the interface, much like a class. Okay, we had a coffee provider class, okay, but we get a complaint saying we haven't provided a method body, and you might be thinking, well, interface looks a little bit like an abstract class, and you would be right, very similar. If I say abstract class and abstract function, then we have an abstract class. We'll come back to this point in just a moment, but for now, much like a class, the word interface and the name of the interface with a capital letter. So if we don't provide any behavior, any method body in the interface, then what's the point of it? And a really, really good thing I got told a while ago to help me understand what role interfaces play in our code is to think of an interface like a contract, a promise. If something says, hi, I'm a coffee provider, I implement the coffee provider interface, what they're saying is, I guarantee you I will have these methods exactly like this. I will have a greet method which takes a name string and returns a string. I will have a method that serves coffee. Okay? So that's a really good thing to think of when working with interfaces. So let's make a note to say this. Think of interfaces like a contract. If something is a coffee provider, then it in the interface. Once we've defined the interface name, then we type out all of the methods, including any parameters or return types like you see below, we want but we don't write a method body. So that just about wraps up our introduction to interfaces and how to create them. So let's now dive into how we would implement these interfaces. And when we say implement, we mean how we would write out the code to actually do this behavior. So let's make a simple class, and this class can be a fictional coffee shop. So we'll say class, and we'll call it easy coffee. Okay? And much like with inheritance, the way that we set autocomplete. And then we do the curly braces, and then we have our class body. So straight away, we're getting a warning. And I hover over that warning, it's saying the class easy coffee isn't abstract, and it doesn't implement the abstract members serve coffee and greet. So what that's saying is we're promising that we're a coffee provider. We're promising that we have the behavior serve coffee and greet, but we haven't implemented those methods. And we're not an abstract class. We can't have unimplemented methods like that. Okay? So we can go ahead and use the error now to actually create those two methods. So I'm going to do Alt Enter or Option Enter, implement members, and making sure I select both of these two methods in our coffee provider. I can see here our interface methods with them selected, pressing OK, and then we have our two interface methods, serve coffee and greet. I'll just delete the to do in both of those. And just for fun, I'll move the greet method to the top, as we'll do this one first. OK. And we'll return an empty string for now. So above, we've defined our interface, we've specified our contract, the things that coffee providers must promise to do. And below, we have a class, exactly like extending. Apologies for the long line. If I make a new line, we can see exactly this here, colon, and the name of the interface, just like inheritance. It's probably worth saying, just so we know if we ever see Java code, that in Java, it is done with the word implements. For example, public class my Java class implements my Java interface, and then the class braces. Okay, so just for reference, that's how we do it in Java. And the final point to note is that once you state you are implementing, to fulfill the contract. So let's scroll down now and actually provide some behavior for our easy coffee. We'll use our one method and say some complicated way that easy coffee's finest coffee. Say it's of type easy coffee. I can do this. Okay, and I'll make it a new easy coffee object instance. You can see there, and we can do easycoffee.greet. I'll do my name, and if I look to the right and scroll down, welcome to easy coffee Vin, so that works. And I can also do the serve coffee method. Here is easy coffee's finest coffee. But the beautiful thing is, as well as saving it as a variable of type easy coffee, if you think back to that bonus tutorial on polymorphism a while ago, I can also save it as a variable of type coffee provider. So now if I scroll down, I see it still works. I don't know anything about the easy coffee class. I just know that this is a coffee provider. I know it will have those two methods because it's in the contract, it's in the interface, it's promised to have those methods, and so I can use it just the same. So this leads to our first benefit to interfaces. If I actually now make another method in easy coffee, a new one called the easy method, to our first, those two methods because it's in the contract, I don't know anything from a while ago, I can also save it as a variable of type coffee provider. So now if I scroll down, I see it still works, and so I can use it just the same. So this leads to our first benefit to interfaces. If I actually now make another method in easy coffee, a new one called the easy method, and I'll move the complicated fictional code that we haven't typed for serving coffee into there, and instead I'll just call that method, okay, the easy method. I'm not going to make the method private, so it would be possible to access this. So if I change this back to an easy coffee variable, I see that we can do easy coffee dot the easy method, okay? But if I change it to a coffee provider, then I don't know anything about this method. And we'll type it above the serve coffee method, this comment, so **, or the launchpad icon on the Mac, and it will show all the apps that are installed on our machine. There's probably quite a lot of complexity in the computer to go to the hard drive, find all the applications, and then get the image icon for that application and show it on the screen. But the user doesn't care about that. We just click on an icon that says, show me my applications, please, and up they come. So the interface, the user interface of the computer hides that complexity. And the same thing happens here with our coffee provider. So this is a coffee provider. So we know it has the method to serve coffee. The caller of this method to know that it can serve coffee. I'm just going to comment out this line and say, this won't work. Coffee providers don't have this method. So I'll do another class. This time I call it coffee for you. Okay, again, it's a coffee provider, and I'll do the class curly bracket. We probably want to override. And for greeting, this time we will do, and then again, we'll have some hidden use process. Okay, so we can call that inner working code inside our serve coffee method for you, coffee. Okay, and I'm going to go ahead and just copy spelled wrongly. And greeting can be something like, you've made the best choice. Code, and we'll just say something like classes, easy coffee, coffee for you, and best coffee, and they are all coffee providers. They all promise to have these two methods, greet and serve coffee. So we can move on now to a second reason why interfaces can be good. So you'll notice for best coffee and coffee for you and easy coffee, they all have an extra method, their own secret inner workings, their own secret way of doing it, okay? Well, the big second reason is this. So why reason 2? We don't need to make the whole class available to other parts of the code, just the interface methods. Okay, if I make a quick variable of type best coffee, so val best coffee, and I'll make this of type best coffee, so the actual class, not the interface variable type, and we'll say this equals a best coffee instance. Well, if I'm just a plain old simple coffee drinker, I just want my coffee, but it's possible for me to directly tell them to go and do it with the best method. I can directly call this complicated technical code. And it might not always be safe or appropriate for me, the coffee drinker, to know these things. So we can put a comment above this method call to say exactly this. It might not always be good to make the inner workings of a class available like this, okay? And at this point, it's slightly confusing you. Let's bring it all the way back to our activities, okay? If I go back to main activity, and if I actually just undo things to get the button click listeners back, I'll remove this. So we have this view click listener interface. We have this part of the activity that's saying to our buttons, hi there button, I can handle clicks. I'm a click listener. I promise to do this behavior. I promise to have an on-click method. Okay, it kind of happens with a bit of shortcut inside here. So we say to the button, here is the code to handle the on-click. But we could just pass the whole activity to our button. We could do something like button cycling.setActivity, and we could give the whole main activity to the button, and we could promise that every single activity will have an onClick method. Yeah, we could have an onClick method in every single activity as part of app compat activity, and then just say to button, hi, here I am, the activity, you have reference to me, the activity, and you can call my onClick method directly. Well, the problem with that is the button wouldn't just have access to the onClick method, but it would have access to everything. It could call onCreate. It could call some other lifecycle methods we haven't seen yet, like onDestroy. Okay, it could actually control the slightly dangerous inner workings of an activity. So we don't want to make the whole activity available to our button or to our button navigation view. We want to use an interface, so the button can only see the methods that it needs to see. Okay, so I'm going to go ahead and delete the onClick code there. Go back to our Scratch file. So reason 2, we don't need to make the whole class available. Again, like we saw before, if I make it type coffee provider, I still make it the same object, the best coffee object. Of course, best coffee 2. There we go. Okay. Well, now we can't see the inner workings. We can just see the method that we need, serve coffee. So we're pretty much through what interfaces are and a couple of good reasons why we might need them. There might be some of you who might remember the lessons on inheritance and abstract classes who might be thinking, well, couldn't we do all of this with inheritance? Couldn't coffee provider just be a class, an abstract class, and then best coffee, easy coffee, coffee for you can just extend coffee provider rather than the interface? There is a subtle distinction there between, yes, a parent, abstract class, and an interface. And this leads on to reason 3 for why we use interfaces sometimes and not always inheritance. So why reason 3 is this. Many totally different types of thing can implement an interface. Okay, so sometimes inheritance doesn't really work. All sorts of crazy different things could be a coffee provider, not just shops. Okay, it could be a shop, it could be a vending machine, a machine. It could be a family member if you're lucky. Okay, they can provide coffee. A shop might already be a type of building. Serve coffee by being a coffee provider. So we use an interface to make it really easy for any class to promise to fulfill certain behavior. Okay, so we'll say just this. We will make a fourth and final class. We'll call it class man with a scroll down a little bit. I'll do my easy shop. So the greeting comes, and we can have a coffee shop and back. Okay, so the way that a man with a bicycle serves a coffee is he goes to get the coffee before then serving it to our user, the person. And just as a bit of a fun bonus, at the very end of the class, we'll have a bit of fun with polymorphism and for loops. So shop 1, and we'll say it's a coffee provider, best coffee, and it's man with bicycle. So let's now make an array of all of these coffee providers. So we'll do val our coffee providers, oops, capital P, and we'll say it's an array of type coffee provider 1, shop 2, oops, the name of the variable, and then curly bracket, I'll greet all of the for loop there. Greetings Finn, please don't make me go do the behaviors that you want. Fill out your contract. That's all it does. It says that a click listener must promise to have an onClick method. That's all it is, okay? And then when it comes to making your classes that implement them, you do a colon and then the name of the interface, and then just fill out the methods. And that's all there is to it. And we think of an interface as a layer between two subjects, two parties, a user and a computer, a coffee drinker and a coffee provider, okay? And in the next tutorial, we'll go back to main activity. We're going to make our on navigation item selected listener, which is an interface. We're going to fill out the interface so that our bottom navigation view can handle clicks. And as well as looking at the on navigation item selected listener, we're going to have a look at 1 or 2 different ways we can actually do that. A couple of different ways we can make the interface so we can respond to the bottom navigation view. So if you don't immediately get every single word in this interface concept, don't worry. But as we start using them, as we start seeing them more and more in this course, I'll keep making reference back to this. So the concept of interface. We now know what interfaces are, and in learning how to implement interfaces, we've seen a few good reasons why we would use an interface, why they're useful. So it's time now to go back to our project and actually implement the interface we need for our bottom navigation view. And in doing this, we're going to finish off the concept of interfaces by seeing a few different ways of how we can implement the interface. There's actually a couple of extra ways we can implement an interface to what we've seen in the previous tutorial. So this final tutorial, getting us set up in our project, will show you the how we can go about implementing this interface in different ways. And to show you what I mean by this, we're actually going to start first of all with our button click listeners, that interface, before moving on to the bottom navigation views listener. So underneath set content view, I'm going to put a reference to our buttons again, so binding.button cycling. I'll just use one button for now. So the interface for a button is a view.onClickListener. If I just do dot and do set onClickListener, and I'm going to choose the top method, the one with normal brackets, not the shortcut one with the curly brackets. So this top one here, you can see it's expecting a view.onClickListener. So one way that we could go about implementing the onClickListener interface, very similar to what we did in the last tutorial, is make a brand new class and have that class implement the onClickListener. So I'm going to do exactly this. So in the project pane, I'm going to right click, do new Kotlin class. I'll call it my click listener. Make sure it's selected on class. And we'll do with the colon sign implements view.onClickListener. And you can see we're getting a warning, and that warning is telling us that we haven't implemented the method onClick. If I command click on the onClick listener, you can see the interface is expecting a method called onClick. That's in the contract. We must do this. So I'll use that error to make the method. So Alt Enter, Option Enter, implement members, and then we have our onClick method. Okay. So I've made a brand new class. If I go up to main activity, I can make a new instance of that my click listener class. So I'll do this, the click listener. I'll make it of type view.onClickListener. So we'll save it as the interface type, and I'll make this equal to a new my click listener object. This class you can see at the top here that we just made. And because this variable is saved of type onClickListener, I can pass it in to the set onClickListener method, and that will work absolutely fine. If I just show you a quick secret of Android Studio and have these two files next to each other, I'm going to right click on my click listener and do split vertically. Okay, and I'll put the two files side by side. Well, we've got one problem with this completely separate class, my click listener on the right. This doesn't know anything about activities. It doesn't know the main activity that we're inside. Because this class doesn't extend app compat activity, it's a totally separate file. I can't do something basic like toast.make text and get the context. I have no access to context. That's a feature of app compat activity on the left. So this approach of making a brand new class in a totally different file is no good. We don't have access to anything inside main activity, and that's a real problem. So I'm going to close the vertical split. I'm going to go to the project pane and actually delete this my click listener class. We can implement interfaces this way in a brand new file and just extend the interface, but it's too separate from our activity. This approach is no good. So I'm going to delete this. So making a separate class is going to be no good for our example here. We need some sort of interface that has access to main activity. So I'm just going to go ahead and delete this line and the variable. So the next approach is to actually make main activity itself implement the interface. So I'll do exactly this. So something new now, we can see that main activity is extending app activity. So the way interfaces work is they go after any class extension. So we're extending app activity, we've got the curly brackets for that parent activity constructor. So all we do is we put a comma, and then as many interfaces as we want. We can only extend one thing, but we can have as many interfaces as we like. That's one of the main big reasons why we use interfaces. So I'm going to have main activity implement view.onClickListener. And again, the class has an error saying we're not implementing the methods. This time I'm going to go ahead and type them. So underneath onCreate, before onRunningClicked, I will do onClick, and you can see I get the prompt to override this. So I'll use autocomplete, and now the error goes away. And this time, if I do toast.makeText, I don't need to type context, I can just do this. This is the context, and this is the activity. Because in Android world, an activity, an app activity is a context. So this works just fine. And then I can go ahead and do my message. I have made the activity a click listener. Toast.lengthlong and .show. So the way we register with the button that this activity is a click listener is we pass in the word this. Okay, so we're passing in main activity. And in this bit of code, it's going to look at the activity and check that it implements view.onClickListener, and it does. If I remove this interface call, you can see I get an error saying we require an onClickListener, but we only found main activity. But if we have main activity implement the interface, then we're saying I promise to have the onClick method, I am an onClick listener, I can fulfill the contract. And so set onClick listener brackets this works absolutely fine. So this is a really good way to implement interfaces for things in our layout code. There is, however, just one problem. Let's say I change the message to I have clicked on the cycling button. Well, what happens if I need to provide some different code for the running button? So I'll go ahead and do binding.buttonRunning, set onClick listener. I'll do this again, and that works fine. Well, when button running is clicked, it will also call the same onClick method. So one drawback of this approach of making the whole class implement the interface, and then for the set onClick listener just passing in the whole class, like this, is it only allows you to have one call and get the ID. And we can say if the ID equals r.id.button equals r.id.buttonRunning. But it'll be called if any of our buttons get clicked. But in the interface, if I go back into the onClick listener interface, you can see that when the method is called by the button, so the button will call onClick, well, the button passes itself into the parameter. It passes a reference to the button that was clicked. So we can look at that view's ID. It's called v here. I'm going to rename it to view, which I think is a nicer way of calling it. So if the view's ID matches the ID we're expecting, then we can have different code. So that's one way around that slight problem. Okay, and actually, some professional projects do use this approach. It's okay to do this. It's not the way that I personally do it for buttons, but you can do this if you have more than one button requiring the same click listener. So I'm going to go ahead and remove this onClick method, and I'm going to remove the onClick listener interface. And now this won't work. I'll delete this from both brackets. The activity class can be done, but then you get quite a big onClick method, and that method will get bigger and bigger the more buttons you have. If all those buttons are sharing the same interface, then there can only be one onClick method. So that approach might not always be ideal. So the final approach, and it's probably the most complicated sounding, but for buttons it becomes the most useful, is the concept of an anonymous class. So that's a scary sounding term, an anonymous class. But what it means is, it gives us the ability to essentially build a class right in line inside our code, inside our method, not give it a name, not make it a separate file, but provide the implementation in line. And way back when we did Java and we saw our first button click listeners, there's a whole load of crazy code that was made, new view.onClick listener, and I told you at the time that there were some things that you probably wouldn't understand at that point, but I would come back to and explain later in the course. Well, right now we're going to dive into some Java, a Java activity class. We're going to look at that code and finally unpick what it means and see how that is actually creating what's called an anonymous class, which isn't as scary as it sounds. So in my project pane, I've gone ahead and made a main activity Java file. You don't need to do this. Feel free to just follow along with this tutorial. So in main activity Java now, I've tried to copy the same onCreate method, but in Java. So this may look vaguely familiar to some tutorials from a long time ago. Public class, main activity, extends, rather than colon, app compat activity. We have our binding variable with a variable type in front of it, and we have our onCreate method. So underneath binding.getView, I'm going to create a view onClick listener for our cycling button. So I do binding.buttonCycling.set onClick listener, and you can see that's expecting a variable type onClick listener. So we can actually create an anonymous class in line right now, and the way we do that in Java is by simply typing the word new, like we're making a new object, so new, and then we'll do view.onClickListener. I'm going to autocomplete that, and you can see it puts in the brackets there, so we're making a new onClick listener object, and then immediately after that new instance, we do the class curly braces. Okay, and we're getting a complaint, and the complaint is saying you must either be abstract or implement the onClick method. So this gives us the opportunity to implement the interface right here, right now, in a class that has no name. That's why it's called anonymous class. And you can see the words anonymous class there in the helper prompt. So again, if I alt enter option enter on this new, ignore the this is just happened to not name it anything. And I can type this will work, toast.lengthlong, and show. It's called class myClickListener. We just do the new word, and then we implement the interface right here. And the beautiful thing with this is we can do this right inside an activity and have access to everything in the activity, including even the binding if I needed it. It works a little bit differently in Kotlin with one new term, one new word which we've not seen before. So we'll just jump back now to main activity. I'm going to go ahead and delete this main activity Java class. So right click delete, we don't need that. So the way you do anonymous class in Kotlin is, in my opinion, a little bit easier, so a little bit shorter, but it introduces a word which might seem confusing at first. I know it confused me when I first switched from Java to Kotlin. The way we do an anonymous class is with the word object. So start typing object with a lowercase o, and you can even see that it prompts you to do anonymous class. And if you select this, it gives you a nice little shorthand. Don't do this. Instead, just type the word object, and you can autocomplete the top one. Don't autocomplete the anonymous class one. We'll do this ourselves from scratch. So we'll do object, then you do a colon. So the word object is like saying, I am an anonymous class. I'm just an object made right here, right now, a class with no name. So the word object implements, so the same syntax like making a class that implements interface, and then the name of the interface. So object implements view.onClickListener. That's the Kotlin way. We don't do the normal brackets for interfaces, we don't do that, but we do the class curly braces. So do the curly brackets and then enter. And this effectively is making a brand new interface class, an anonymous one, an object one, right here. And the error on the object says the same thing. It's not abstract, it doesn't implement the member onClick, so we can use the error, or even just type the error, which I'll do. So onClick, autocomplete, and that's how you do it in Kotlin. So this object view.onClickListener, this is our anonymous class. We are implementing the interface right here. And certainly for button click listeners, especially when you have more than one button, in my opinion, this is the preferred way. You can have individual on-click code for every single button. You don't need to dump it all into one giant activity on-click button. Instead, you can separate it nicely. So I pretty much always do this for my on-clicks. But you might be thinking, well, hang on. I used to see my on-click listeners like this. If I show you in the running button, just normal curly brackets. Well, if I put some code here, if I just say, refer to something, I don't know, bottom nav, just a tiny bit of code. If I then go to this helpful little suggestion, it's saying we can convert this to a lambda. And without doing a deep dive into another technical term for what lambda really means, a very simple version is it's just a shortcut using these curly brackets that implies all of this. So if I do Alt-Enter, Option-Enter, convert to lambda, well, we finally get back to what we started with on Kotlin, set on-click listener and these brackets. So wow, that's a long way to get back to where we started, but now we finally understand what's happening under the hood. Under the hood with this lambda, these curly brackets, it's essentially implying an anonymous class that extends an interface. If I undo that, object, Kotlin's way of saying anonymous class, implements, view.onClick listener, the class curly brackets is as if we're actually writing out a class, but the class has no name, it's just the word object, and then we do the method. And all of this can be made into a shortcut, a lambda, which is where essentially Java and Kotlin imply all of this. It knows that this onClick listener is expecting an interface, so we can do convert to lambda, and we have the shortcut to the onClick method. Okay? If you don't understand every single little bit of that, it's absolutely fine. The important thing is that you finally see what's happening under the hood with anonymous classes. Anonymous classes, in my opinion, are by far the best way to handle individual button click listeners. But the next tutorial, where we finally implement the listener for our bottom navigation view, our on navigation selected listener, we're going to have a choice as to whether we do this lambda, this shortcut to an anonymous class, or indeed actually just pass in this main activity. I have my preferred approach for bottom navigation views. You're going to have the choice once we've seen the different ways we can do it. But now as a developer, you're fully equipped by knowing what interfaces are, why they're useful, and the different ways of how we can go about implementing them. So let's move on to our bottom navigation view interface.